Hello. Today, let's quickly go on with the topic of symbol table manager and error handler. Initially, let's discuss the symbol table. It is a data structure that contains information about identifiers, array names, subprogram names, parameters, etc. Example, A equals B plus 10. Here, A is an identifier. Equals is an operator. B is an identifier. Plus is an operator. 10 is a constant. The symbol table contains all the symbol-related information. That is, identifiers, names along the types are also stored here, so, the main use of the symbol table is it makes it easier for the compiler to quickly search the identifier records. Symbol tables are data structures that are used by computers to hold information about source program construction. It is used to store information about the occurrence of various entities such as objects, classes, variable names, functions, etc. It is used in both the analysis phase and synthesis phase. The symbol table used for the following purposes. It is used to store the name of all entities in a structured form in one place. It is used to verify if a variable has been declared. It is used to determine the scope of a name. It is used to implement type checking by verifying assignments and expressions in the source code are semantically correct. A symbol table can either be linear or a hash table. It means the entry for each name as symbol name, type, attribute. Example, static, int, salary. Next, implementation of symbol table. The symbol table can be implemented in the unordered list. If the compiler is used to handle the small amount of data, a symbol table can be implemented in one of the following techniques: linear sorted or unsorted list, hash table, binary search tree. Symbol tables are mostly implemented as hash tables. The operations provided by the symbol table are: insert. It is more frequently used in the analysis phase, when tokens are identified and names are in the table. The insert function takes the symbol and its value in the form of argument. Example, int x should be processed by the compiler as insert x int. Lookup. It is used to search a name and it determines as the existence of symbols in the table. Declaration of the symbol before it is used. Check whether the name is used in the scope. Initialization of the symbol. The basic format of lookup function is lookup symbol. This format varies according to the programming language. Symbol table organization. It is stored in the form of a table. So here, it is stored in the form of a stack. So, let's have a symbol table for three values. One is for symbol table procedure Q and another one is for symbol table for procedure P and another one is for symbol table variable X and Y integers. Next, representing source programs. Every name possesses a region of validity, called the scope of that name. The scope is the lifetime of a variable. It is the area under which a variable is applicable or alive. Let's consider a particular variable A. That a variable is used within the block in which the area is applicable or alive. So, the actual definition of scope is a block or a region where a variable is declared or defined. When a block ends, that is when the area ends, then the variable automatically destroys. So, the scope variable has two types. One is a local variable and a global variable. Let's consider an example for local variable, as, here, scope of the variable is within the main only, therefore called local to main function. Next, let's consider an example for global variable. The scope rule needs a more complicated organization of symbol tables than a list of associations between names and attributes. Next, example is, here, we can see the symbol table organization that compiles with static scope information rules. Next, symbol table data structure. The data structure should be designed to allow the compiler to find the record for each name quickly and to store or retrieve data from that record quickly. 1. Linked list. A linear list of records is the easiest way to implement a symbol table. The new names are added to the symbol table in the order they arrive. Whenever a new name is to be added, first it searches linearly to check if the name is already present in the table or not. Let us see here how the linked list works. Here is the diagram of the linked list. Initially, it is stored in a linear format. Here let's consider 5. Let's take it as a name that is store. In the symbol table, if the source code sends 5 again, it checks whether the symbol table is present or not. If it is already present it will take, if not it will reject. After taking it will insert using insertion operation in the symbol table. And the time complexity of the symbol table is big O of n. And its advantages it consumes less amount of space and additions are simple. And its disadvantages are higher access time. Next. 2. Binary trees. It is an efficient approach for symbol table organization. We have to add 2 links left and right in each record in the search tree. Whenever a name is to be added, the first search in the tree, if it doesn't exist then a record for a new name is created and added at the proper position. This has alphabetical accessibility. Consider an example, for suppose, 2 is not there in the binary tree. Initially, it will check when the source code sends the particular name to. It will check whether it exists or not. If it exists already it will be rejected. If not it will receive the name too. So here, we can see the alphabetical order of binary trees. Next. 3. Hash table. In a hashing scheme 2 tables are maintained. A hash table is an array with an index range, 0 to table size -1. These entries point to the names of symbol tables. To search for a new we use a hash function that will result in an integer between 0 to table size -1. Insertion and lookup be made very fast are 0 of 1. Next. Error handler. It is used to detect the error then report errors in the source program during different phases. In a general way, let us take in lexical analysis phase. A equals letter. Equals is equal to symbol. B is number. Plus is an addition symbol. 10 is a letter. So, here by this example, B is mentioned as a number and 10 is mentioned as a letter. So using the error handler it detects that error and reports that error to the user. So it corrects it as B is a letter and 10 is a number. Next coming to lexical errors. Lexical errors are also called source code errors. While reading or scanning the source code if there is an error that error can be raised by the lexical analyzer. Generally, lexical errors are very difficult to identify because the errors raised are misspelt identifiers, keywords, operators etc. So, the lexical errors are nothing but, the character sequence does not match with valid tokens. Syntax error. Syntax errors will appear during the syntax analysis phase. It is found during the execution of the program. Some syntax errors can be error in structure, missing operators, unbalanced parenthesis. Example, using equals when equals is needed. Next. Semantic errors. Semantic errors occur during the semantic phase. It is declared at compile time. Semantic errors can be in compile type of operands, undeclared variable, not matching the actual argument with formal argument. Example, use of non-initialized variable. Here is an example. So, here, D is undeclared, it shows semantic error. Well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.